We were talking about forces acting on objects last time, and we had discussed some types of forces that we might meet acting on an object. And before we go on to solve some problems, I would like us to discuss the correct expression to use when we talk about forces, because it can save our lives sometimes. Sometimes, very often, we hear some silly expressions like, and this object has a force so and so, or there is a force in the object, or the force of this and the force of that. These are not good expressions to talk about forces. When we talk about a force, an important thing is to hold it now, because this pen doesn't seem to respond. So I hope you can see the screen that I have here. Siobhan, can you hear? Yeah. All right. There are two very important words that we need to use when we talk about the force acting on some object. We need to, these two little words is the word by and on. A force is exerted by an object on some other object, and we need to include these two little words if we want to speak properly about forces so that other people understand. So, for example, we have this guy here falling from an airplane before the parachute is open. There are two forces. They show two forces acting on this person. This downward force is the weight. It says here weight. The weight. And this upward force, it says here drag. It's the air resistance. So how do we talk properly about these forces? The weight, for example. This is the force exerted by the earth on the man, on whatever, the parachutist. So by the earth on the man. And this on actually specifies where does the arrow of the force supposed to start from. So we started from the man downward with an arrow to show this force. The other force is exerted by the air on the man as well. By the air on the man. By the air on the person, on this person, whatever he, on the man. So these two little words are very important because by corresponds to which agent, what exerts this force, because some other object has to exert the force on the object we are talking about. So this corresponds to who or what is the agent that exerts this force, and this corresponds to on what this force is exerted on, the object that experiences this force. So let us try and practice a little bit these little words on these pictures. We are given here something like 9 pictures here, and we are told show one force acting on the object indicated in each picture, and we are going to refer to this force properly. So they tell us to draw a force acting on the wheelbarrow. It doesn't mean that each object here experiences only one force, but they say draw just one force. So on the wheelbarrow, what forces act on the wheelbarrow? Well, I suppose the force the force of interest here is the force exerted by the man on the wheelbarrow. So what is the direction that this force acts? Well, we assume that this man is pushing the wheelbarrow. So let's say that this will be the force exerted by the man on the wheelbarrow. So by the man on the wheelbarrow. Here we have a toolbox falling on somebody's foot. So what force acts on this foot due to this falling box? Well, this force has a direction, a downward direction. It acts on the foot. So how can we express, what can we say about this force? We can say this is a force, this force acts this force is exerted by the toolbox on the foot. So by the toolbox, by the box. This force is exerted by the toolbox on the foot. Now on the box, well, obviously this guy is picking the box up, or at least he's holding it and walks. So what force is exerted on the box by this man, by the hands of this man? There is an upward force that keeps the box in place there. So this force is exerted by the man, or by this person behind the box, by the, I think it's a man again, by the man on the box. Now, a force acting on the wagon. Well, it's the horses that pull the wagon. So there's this pull here to the left of the picture. This is the force acting on, at least one force acting on the wagon by the horses that pull it. So we can say that this force is exerted by the horses on the wagon. And here on the masspiece, well, this guy is pulling this masspiece with a string, with a rope. Here is the force acting on the masspiece because it is being pulled by the rope. This is the force. And we can say that this force is exerted by the man on the masspiece. Here we have two children pulling a teddy bear. Well, this teddy bear, we can draw two forces actually. One force is in this direction, exerted by this boy. This force is exerted by the boy on the right, by the boy on the teddy bear. And there's another force exerted towards the left by the girl. I don't know what it is. Does it look like a girl? By the girl on the teddy bear. So we have, well, logically we should draw those two forces, both pulling on the teddy bear. The one's exerted by the boy, the other one's exerted by the girl on the teddy bear. Now this girl again now is pushing a bicycle. In which direction does she push? We suppose she pushes forward. Let's say this is the force exerted on the bicycle by the girl. So this force is exerted by the girl. And okay, what is this now? This backpack. Force acting on the backpack is upwards, exerted by the man on the backpack, by the man on the backpack. And here, what do we have on man's head? What is this? A draw. A draw hitting this man on his head. Well, the force on the man's head is in this direction, exerted by the draw. Draw, yeah, on the man's head. So there are some forces that we have drawn here, just to practice talking about by what is exerting the force on what. And it's important to know how to use these expressions, because we are going to use the same expressions later on when we talk about work. Again, when forces do work, we have to say who does the work, by whom, on what. So it's good to learn to behave properly in our expressions. And there's a similar exercise in this workbook, but hold it, let's see. Yeah, there it is. Look at this. Maybe you have this workbook or maybe not. If you don't have it, it's not the end of the world at all, because I can show you something. Like there is a problem here identifying forces. It says each force arrow should be labeled to indicate the following. The pictures show some bodies. They mean the pictures here in the next page. The pictures show some bodies. Your task is to add at least one force arrow to each body, showing a force acting on it. Let's make it a bit bigger because it might be too small for you to read the fine print here. So here is a problem in the previous page too. Your task is to add at least one force arrow to each body. And each force arrow must indicate the type of force, whether it's contact, drag, air resistance, blah, blah, blah. The body causing the force, which means this little word by, and the body acted on by the force, which means the on word. So they say they already show two forces, one on the up. Here are the pictures. They give us 6 pictures. Here they have already a force on an apple and a force on a car. I don't know if they want extra forces there, but there are extra forces that we can add. For example, on the apple, as it falls, what other force can act on the apple? Obviously, this downward force must be the weight. It's weight exerted by the earth on the apple. Another force we could draw here would be the air resistance or drag. We call it F, air, to say that this is the air resistance exerted by the air on the apple. For the car here, well, we assume that this car moves to the right because they show these little lines as if this car is moving to the right, and which means that this force obviously must be the propelling force of the car. Propelling force. Propelling. What symbol could we give this force? We could call it FP to show that this is the propelling force. This propelling force, no, this is a bit tricky to say what exerts the propelling force on the car, because many would think that the propelling force is exerted by the engine, but it's not exactly that. Nevertheless, it's not for your level actually what exerts this propelling force, so we can say by the engine for the time being. Is the force, in other words, that causes the car to move forward when we start the engine. But there is another force acting on the car which opposes the motion of the car, which usually we call it drag or air resistance or friction or whatever. We can give it the symbol FR if we want to. So this force is exerted by the air on the car. Always the by and the on. Next, we have like a child sliding down the slide. Well, okay, of course, this boy will have a weight always vertical to the ground. Look at the direction of the weight, always vertical to the ground. Weight exerted by the earth on the boy. We could also draw the force of friction, because when things slide, usually there is friction. And if obviously the boy slides downwards, which means the force of friction is in the opposite direction to the motion, opposes the motion. We can call it F friction, this one exerted by the surface of the slide on the boy. All right, so we have the fish. We assume the fish is in the water, and we also see these little lines, which is like showing that the fish is moving to the left, isn't it? Perhaps this is what they mean by these little lines here. All right, the fish. Obviously, the fish is fish has a weight like any other object. The weight of the fish exerted by the earth on the fish. And of course, there must be an upthrust force exerted by the water on the fish of upthrust. Now maybe we can give it the symbol F up, say, for example. There might be other forces as well. I mean, since the fish is propelled to the left, obviously there is another force acting on the fish, a horizontal force on this direction, isn't it? which perhaps is excited by the way that the fish moves, and especially its tail, and propels the fish forward. I mean, if we want to, we can also put down this force. How can we call it? Propelling, we can call it propelling. Exerted, actually, this force is exerted by the water on the fish and propels the fish due to the way that the fish moves. Which brings us to the point, what does propel the car? Actually, don't want to confuse you, but the propelling force on the car, you might be surprised to know that it's actually exerted by the road on the car. So if you are not aware of that, please don't be confused. When the time comes, you will understand why it's the road that exerts the propelling force. Anyway, now the last two objects we have this magnet, which exerts forces on the magnetic objects, like a paper clip. Well, the force on the paper clip, for example, would be upward, attracted by the north pole of this magnet. Let's make a big arrow so that we can see it, because the magnet is black. And okay, there will be this force, let's call it Fm for magnetic, exerted on the paper clip from the magnet on. Let me say that again. This magnetic force Fm is exerted by the magnet on the paper clip. By the magnet on the paper clip. Okay, and the last picture shows a boy pushing a box. We suppose it pushes in this direction. There will be this pushing force. You can call it F. Sometimes in books it appears as F applied with an A. Anyway, this is the force exerted by the boy on the box. Okay, by the boy on the box. What other forces could we draw here acting on the box? Well, obviously the weight, W, and also the one force that is called contact in your book, which is the normal force, actually, the normal force, F normal or F contact, okay. And since the boy pushes the box on the right-hand side, obviously there is a frictional force between the box and the floor and the ground, which opposes the motion. It's in this direction. In other words, let's call it F friction. And usually these are the forces that would act under normal circumstances on this box.